Welcome back to Learning Here with me at MPB. This is the last lesson of our Unit 7, Working with Quadratics. We're on this last lesson. We're looking at transformations of independent variables of quadratic functions, where we are applying horizontal shifts, stretches, and compressions to this function. We're looking at these quadratics. We're looking at FBF3. So let's go ahead and dive on in. Let's do some remembering. All right, so when I have my y and I have it equal to some type of equation, and in that equation, I'm adding inside the parenthesis to that x, I'm going left to right. Remember, when I'm adding, I go to the left. When I subtract, I go to the right. When I have that equation and I'm adding and subtracting on the outside of the parentheses, I'm going up and down. Adding goes up, subtraction goes down. And then I have that stretch and compression depending on what I am multiplying by. So let's go into some problems. Now, let's do some practice about this. This is the continuance of our last lesson. So it says, consider the information given and complete the table. What happens when you add a positive constant? We use the brown table to find our f of whatever we're looking for, and if you follow the math, it will compute. Now, this looks like a lot. You're looking at my screen and you're looking at your papers and you're saying, Ms. Killen, this looks like a lot. Okay, we're going to walk through it, we're going to look at it together, and I promise you it's going to make sense. So let's look at the math. My t, or my x values, are -4. I am looking for my new y value, which would be g of t. So when I have g of t equals f of t plus 2, that's where I'm going to get my new y value. So let's look at this math real closely. G of -4 equals f of -4 plus 2 equals that -2. So when I have f of -2, I come over here to f of t where it's -2 and I get a 4. And that is my new y value. These are my x, this is my y. So this is why I have these right here. This is what I'm referencing back to over here to find my new y value. So let's look at the next one. If I had g of -3, I would place in f of -3 plus 2, which equals f of -1. So I take this starting point of f of -1 and go over here, and I have a +1. G of -2, I'm going to place that -2 in, so I have f of -2 plus 2. -2 plus 2 is 0, so we go back over here to my brown table, 0, and I have that y value of 0. So when I take g of -1 and do the same thing, plug that -1 in, I'm adding that 2, I get f of 1, I look over here, 1 is my 1, and then the last one is 0. So g of 0, I'm plugging 0 in, f of 0 plus 2 gives me f of 2, and this 2 down here is also a 4. This is how I'm taking an old function, using that information, putting it into my new function to get my new x and y values. That's what we're doing. That's all we're doing. So let's look at some more problems. So now it wants us to do the sketch. So I'm going to take these new x and y values and I'm going to graph it, but I'm also wanting to take these old x and y values and also graph them. So I'm going to graph it up here, you graph it on your paper, and let's see what we got. So I've got 1, 2, 1, 2, 1, 2, 3, 4. So I have 0, 0. I have 1, -1. I have 0, 0. I have -1. Hold on, Miss Killen's messing up here. She put the wrong place. All right, so we have -2, +4, 1, 2, 3, 4. I have -1, 1. I have 0. I have 1, 1. And I have 2, 4. So I don't need that one. So this is going to be my original parent function. There we go. That's my original parent function. So now in the red, I'm going to put my new function. So my new function is negative 4, 4. So here. My new function is negative 3, 1 here. I still have my negative 2, 0 here. My negative 1, positive 1 here. And my 0, 4, which is going to be about, right, 1, 2, 3, 4. We'll put it there. So when I connect these dots, what do you notice from our old function to our new function? What did we do? We added 2. Remember when I said when we add inside the parentheses, what are we doing? We are going to the left. So what we did is we did a slide to the left, 2 whole units. Every single point is doing a slide to the left, 2 points. That's all it's doing. Awesome. So it says, let's look at it in Desmos. So what you can do is on your Desmos calculator, you can go in and plug those different points in and see what it looks like. I took a screenshot. So we had my original, which I put in red. There's my original function. And then I put this new function here, which is in blue. And everything went over 2 whole points. Everything went over 2 whole points. So that's another way for us to check our math to make sure if we can use Desmos. Let's do some more practice. We want to make sure that we are reading our tables, we are noticing what type of transformations they are, and then we're also double checking our work either with our calculator or Desmos. We always want to make sure that we're double checking ourselves. Okay, so now let's look at these different viewpoints of our graphs. My first graph, I have x and g of x, and we know that they are my x values and my y values. Negative 612, negative 42, 112, 790, and 182. Now, what I need to do is I need to know that my f of x equals g of x, but I'm multiplying that g of x by 1/3. Okay, so we need to remember in our head what happens when I multiply by a fraction. We need to make sure that we're remembering that. So let's go ahead and look at this math. So the first thing I'm going to do is I'm going to take and write so I can see myself f of x equals g to the 1/3 x. So the first one I'm looking for is this negative 17 down here. So I'm going to take and I'm going to put in g 1/3 times negative 18. I'm going to take my calculator and just do the math. So in my calculator, I am putting 1/3 in times negative 18. And Ms. Killen, I get a fraction. Nope, you don't because I put the wrong thing in. Got to make sure that you're putting the right thing in. You got to multiply. So I get a negative 6. So when I get here, I get this negative 6. So what I'm going to do is I'm going to go back up here and see what the y value is for my negative 6. And it's going to be 12. That's how we're taking this one function, multiplying 1/3 to it, and getting my new function. So let's do the next one. Let me get a different color. You know, I love these colors. Okay, so let's do a green. So I'm going to take 12. I'm still taking this g of 1/3 times, and now I'm going to multiply it to my negative 12. So let's make sure that we plug this in correctly, like Ms. Killen hopes she does. 1/3 multiply by the negative 12, and I get what? You're right, negative 4. So now I'm going to go up here and look to see what my y value is for a negative 4. And it's what? It's 2. All right, so I'm going to continue doing these. You continue doing the last 3. When you get finished, look up at my screen and let's see if our math is the same. So I'm going to put g 1/3 3, and I get 1. 11. All right, check your work. See where my lines go. That's why I do different colors. When I get what that 1/3 times my x value equals, I go up to my original x and y values, and I see what my y value is for -6. I see what my y value is for -4. I see what my y value is for 1, 7, and 11. This is how I get my new y values for this new graph when I do this transformation by 1/3. Good job, guys. Now it's time for you to master. Look back in your notes if you need to, and remember how we use Desmos to check ourselves, how we're using to go from one x and y value, looking up to that original table to get that y value, okay? Make sure that you're understanding that and looking back. So, if we are given the function f of t equals y squared plus 3, I did the effect of the graph of f of t by replacing t with the following. And again, Ms. Killen forgot to put that as a t. All right? So go ahead and pause the video. You work by yourself or you work with your partner. Get the effects when you compare your k's to 0 and see what happens. And I'm going to be waiting for you. We'll see what we get. All right, here we go. Let's see what we got. When I have my function f of t plus k, and my k is larger than 0, what do you get? Well, I get a vertical compression by factor of k, because k is larger than 0. So what happens when I take this and I am adding k, but now k is less than 0? Exactly right. I'm going to get a shift f of t down k units. Ms. Killen, I think you put the wrong thing at the top. I think you're right, guys. I don't have a vertical shift here. I'm going to have a vertical what? I'm going to have a vertical translation. Good job. That's a good catch. I am going to shift, or sometimes we hear translation, a vertical translation up what? K units. That was a good catch, guys. I'm glad y'all did that. So when I'm adding, when k is larger than 0, I'm doing a vertical translation or a shift up k units. When I am adding a negative, I'm doing a shift or a vertical translation down k units. Now, what about when I'm multiplying when k is larger than 1? I am doing a vertical what? When it's larger than 1, I'm doing a vertical stretch by the factor of k. So then when I'm multiplying by my k, but it is a fraction, it's between 0 and 1, what am I doing? I'm doing a vertical compression by the factor of k. Now look at this last one. I'm multiplying to k, but k is a -1. What happens when I'm multiplying by that -1? I'm reflecting. So I would reflect over the x-axis. Good job. Now down here it says, why do we say vertical for these transformations? So if I am stretching or compressing, I'm moving those points up and down. I've not gone side to side. I'm moving those points up and down. That's why we use vertical. That's a good question, guys. All right, now we need to remember what happens when we add and subtract. Inside my parentheses, I'm moving left and right. And what value is that affecting? My x values, or my independent values. Now, when we add a positive constant to the function, what are we doing there? What did we put in our notes? We need to make sure that we are putting that information in our notes. And we say that our transformations are vertical when my parabola is going up and down, when I'm compressing or when I'm stretching. I'm so glad that you came here to learn with me here at MPB today. I had a great time in Unit 7. Thank you and have a great day.